So when you open GC, you should see this. Everyone get a window like that. Like this. Yeah. Yeah, so you can pull it like a window shade. You can pull the top down or top up. So yeah, either way, if it looks like that, that's fine. Everyone good? Everyone there? Okay, so we just want to go through the very basics of this. And then, like I said, as last time, as we work through and as we move through assignments, you guys are gonna be able to come up with more complex and sophisticated things, and that allows you to, being able to create more complex and sophisticated animations can enhance your teaching even more and more, right? So you're doing this. I'm gonna go through this file that I've made. You're not trying to reproduce this, but we are going to go through it together, and you're going to kind of do the tasks along with it. Okay. So you're looking at a screen like that. So the first thing is, I'll make this bigger. Can you guys all read the text? Is that big enough? It's Ashley, right? Is it big enough to read? Okay. You guys online, is that big enough?
Yep.
Okay, cool. So crash course, here we go. So the first thing is that you can enter what's called math lines into GC or text lines. All this stuff that I'm writing right here that you're reading, that's all text. A math line starts with like that purple ink box, okay? So that's a math line. To get a new math line, you're going to do Control Return. And to get a new text line, you do Control T. And then for text lines, it's just for your own organization, clarity, headers. Like in computer code, you can put text lines in between, the same thing. Okay? So yeah, and you don't really need to take notes on this. Okay, so I'll provide this file to you if you want. But these basic things that I'm going to talk about today, you're going to pick them up fast. Okay. So the next thing is you can use GC for computation. Okay, so the difference between math lines and text lines, and then GC for computation. So you can just type in. So go to on your screen. All you see is this pink link, and so you can just type in calculations. So 6.4 plus 3. Okay, if you want pi, you just type pi. Type pi, and it makes the pi symbol. Okay, for square, it's Shift 2 is a shortcut for square, Shift 2. Okay, you can highlight, so I could highlight this, and then if I hit Shift 9, it'll put parentheses around it. If you have something highlighted and you hit /, that's division. And a really nice thing about GC is it displays these expressions with vertical fractions. You don't have to use all these parentheses and write a long horizontal statement. You can build big vertical as well as horizontal expressions. It's really much easier to see. Okay, so square or cube is, so E takes on its value, and cube is a shortcut, Shift 3. If you want the shortcut for cube, it's Shift 3. Cubed? Cube? Cube? Yeah. Masks, All right, and so then I can say -7. And then for square root, you can do Control Shift R. I thought. Control Shift R. Why isn't that working? Oh, because I did Command Shift R. Control Shift R, give square root. Now on a Mac, there's an easier way you can do Option V. On a Mac for square root, you can also do Option V. But notice what's been happening as we've been creating this expression. I don't know if you've noticed. Whenever there was a valid expression there along the way, it was giving us the current value. Right there, it says equals that number. Okay, so a nice thing, like I said, so it's like a word processor. You can select, you can cut, you can copy, you can paste. So say I want to copy that, and then start a new line, so control return, or on a Mac, it's command return, also works. And then I can paste. And then that comes up again. So now I want to, adjust this. So minus 34. And then if you want any other exponent, you do Shift-6 for the caret and then type in the exponent. So if I want the cube root, I need to do like 1/3. So so all the roots besides square root, you have to put in a fraction version of the exponent.
What is the square root?
Square root is Control-Shift-R. Control-Shift-R gets you square root.
Is there a shortcut for integrals?
Yeah, we'll do that's later though. Yeah, Control-Shift-I. But that we'll get to that later. All right, and so then you could highlight the whole thing, and then you can do that, and now I can multiply this asterisk, Shift-8 for multiplication. Did I miss anything here? Shift-2, Shift-3, Shift-6, pi, a square root, Control-Shift-R. Okay, so yeah, so that's the basics, and then. So right now there's no value showing because it's waiting for something, right? Times what? Okay, questions on just using graphing calculator as a calculator? It's really convenient, like I said, because you can build these expressions and you don't have to try to figure out what the parentheses are in like a big long horizontal. You can see things vertically, which is really nice. So like I can take this whole thing and divide it again, and it still keeps it vertical, right? Great. Any questions on that? All right, so as an exercise here, so practice, so start a new math line on your file, and I want you to write an expression using only the values in the diagram, which are 4, 5, and 9, and 2, and pi. So I'm going to limit which numbers you can use. You can use 4, 5, 9, 2, and pi only. I want you to write one expression for the area of the region that's outside of the circle but inside the trapezoid. So this would be all this kind of light grayish area inside of the trapezoid, outside of the circle. So if you have a question about what dimensions are what, so it's 9 to the midpoint here, 5 to this height of the trapezoid, if that length is 5. This diagonal length of the trapezoid is 9 up to the point of tangency to the circle, and then 4 the rest of the way. Here's your formulas for area of a trapezoid and area of a circle. So go for it. So you're setting up an expression only using 4, 5, 9, and 2, and pi. Find that area. Practicing using graphing calculator as a calculator. Any progress on this? A little bit. Okay. Let's see what you got. Tell me. Good. Okay. So that is good. No, I'm glad you said that because it's like when you work on a problem, you should talk about, like, especially if you're setting up an expression, instead of getting right into the details, like what is going to be the overall structure of the answer? And she said, area of the trapezoid minus area of the circle. That's the right place to start. Okay. Okay. I can't use 0.5. Sorry. 1.5. Good. Okay. 2 times 9. That's fair. Okay. 2 times 4. Okay. So this height, where can we get that height from? Did you get it? Okay. Okay, so 5 squared plus your unknown squared equals, okay, but you have to write it as? Okay. All right, but can't use 13. So you said the square root of? Yeah, 13 is not allowed. 2, 9, 4, sorry, 2, 4, 5, and pi. So you said, I think you said, so tell me exactly what to write. There you go. That's for quantity. Square. Okay. How about that for the height? For the height, Angel likes it. You guys agree? Oh, sorry, I'm not showing it. Yeah, so for the height, she said 9 plus 4 quantity squared minus 5 squared, square root. Okay, and then what? So who was, this was Elizabeth, back to Elizabeth. Okay. So what is the radius? Can you see how the radius relates to something we've already done? So is the diameter the height of the trapezoid? Yeah. So here's the beauty. I can, instead of doing all that again, I can come over here. I can select that and copy. I'm going to need it again, and then come back over here and paste. And is that right? Right. Yeah. Then we have to half it, right? And then. All right. And just square this part. Then shift 2. Now why aren't I getting? I'm not sure why my number's not coming up. Did anyone see why? What's wrong with? It's not wide enough here. Are you guys getting a number to come up? Can't graph equations of this form. It thinks it's me asking it to graph something. Where do I have a mistake here? I don't care about a graph. I'm not graphing anything. Did the rest of you get a number to come up? What'd you get? That's right. It should be 42.9 something something something. Why am I not doing that? Maybe there's just trying to. There's something in there it doesn't like. Does anyone see any symbols? That's weird. But did everyone else get 42.9? 42.9 come up? You guys at home?
I have a question, Ezra.
Sure, please.
GC not accept variables? I tried making like a variable.
Well,
Like,
you're ahead of us. We're just using it to
oh,
do numerical computation. Yeah, GC
oh,
does everything. GC does everything. We're just not there yet.
I wasn't able to get like a numerical results after trying to use variables.
Well, let me just take away a little bit at a time here and see where.
Sorry.
Oh, you're fine. It's the right instinct. I mean, even in this, something is wrong. What's going on here? Huh. Oh, well, I was able to do that. So what do we say? 1/2 of 2 times 9. So every time I have a value, there we go. That's good. Plus 2 times 4. Okay, now we're back on track. Times the height, which was the root of. Okay, I'm the teacher. I can do whatever I want. So I'm going to do 13 minus 5 squared. Still looking good. Is that the trapezoid then? Minus pi. Okay, still looking good. Ah, there was something weird in this expression, this 2 times 9 plus 2 times 4. I don't know what was going on with that. All right, any questions? Okay, another example of this. So the nice thing about this is you can use this as a teaching tool. So rather than focusing on the answer, you can have a discussion with students focusing on the expression. So students can analyze an expression and you can ask them about what do certain things represent, right? So what does this thing in the square root, what does it represent in this situation? What does everything in these parentheses represent in this situation? It makes for a really nice teaching tool because you're not focused on the answer, but you're focused on the expression that builds to the answer and gives you the chance to see it in a nice, very, very clean and clear format to have a discussion about. All right, so here's the next task. So we're going to say, so $100 bill. Huh. So there's something that's missing here from the question. So if we had, so I'll just make it up. So if we had I don't know if any of you were Breaking Bad fans, but there was one scene where they had these pallets of cash in a storage unit, and it was gigantic. So if this was say 3 feet by 5 feet by 1.5 feet, and it was all $50 bills. So let's say all 50s. And here's the dimensions of a bill. One bill is 15.6 by 6.6 by 0.0109 centimeters. So I want you to write one expression that would calculate how much money would be in that stack of cash if they're all $50 bills comprising this block of money, all stacked up close together with just assume no airspace. Is the task clear? That make sense? All right, so one expression that does that, and I'll give you some conversions here. There's 288 1 meter, 2.54 centimeters equals 1 inch. What else? 100 centimeters in a meter. 12 inches in a foot. So now when you guys do this, probably most of us are going to have something different. So we could all have something correct, but we'll all have something different. So go for it. I did this. Can you guys see that? Is that off the screen, or can you guys see that? Angel and Richard.
Oh, we can see it.
The whole thing. Did anybody do it my way? Anyone have what I wrote? So I got, what would this be? 28 million? Is that $28 million? I think that's $28,232,000. Did anyone else get 28 million? No one's nodding. Okay, so I don't want you to abandon what you were doing and copy mine. So that wasn't the point. The point was to check it with maybe a different method. So did anyone get this number? 2.8 times 10 to the 7th be 28 million bucks. So pocket change. You got it? You were able to get it? So did you do the same thing or something different? Similar. Yeah, sure. Yeah, sure. Totally. So what did I do? So again, you can ask a student, what is that I've highlighted? What does that mean? Richard, what would that mean?
Let's see. That gives you the length in meters.
To the length of the pile in meters. Agree? And then Donna, what would this whole numerator give? The numerator. So I'm trying to highlight just the numerator.
Or the area of the palette.
Area of the palette. The area of the palette in meters. Ashley, what do you think? Agree with that? What I highlighted, what does that mean? So it's volume, first of all, and then what's the units on that? Feet cubed? Centimeter cubed? Meter cubed? Meters cubed, right? Because I've transferred all the dimensions to meters. So this would be meters cubed, the volume of the whole palette. And then what about this down here? What about my denominator? Sarah, what's my denominator mean? What's that? The volume of each bill in what unit? Meters cubed, right? So I did everything in meters cubed, and I took the volume in meters cubed divided by the volume of 1 bill in meters cubed. So then how would you describe what that is then? Angel, what would that number be that I highlighted?
Wouldn't that just be a number since the meters cubed count?
Yeah. What number is it?
It is.
No, not the value, the meaning. What is the meaning of that number?
That's how many dollar bills are in there?
Yeah, so it's how many bills, right? So it's the volume and divided by the volume of 1, you're going to get how many would fit in there, right? How many of those bills would fit in that whole cube? Okay, well then multiply by 50. Yeah, so then the number of bills times each one's $50 gives me the amount of money. So did the rest of you, were we able to get, based on your method, not just copying mine, 28 million? Get to 28 million? Ashley, yes. You guys get 28 million? Richard, Angel? So there would be, there could be a dozen different ways to set up this fraction correctly. And this makes for great discussion. Again, like this idea of given the expression, what do all the parts and pieces mean? Okay, enough of that. Any questions? All right, so moving on. We'll skip over that. So free parameters. So most letters are free to be assigned to a value and used in another math line. Changing the value of parameter will update the value of any and all associated expressions that have that in it. So you could come here and say A equals 5 and B equals 36. And then I could do A. Now notice, as soon as I type A, what happened? It told me what the value of the expression is on that line. Well, A has the value of 5, so it's telling me that A is 5. A minus B, negative 31. Now what if I do A minus B plus C? What just happened? Now it's showing negative 30. Why is it showing negative 30? What value is that? So I never defined C, right? I never defined C anywhere in this file. So what value for C does it have? 1, right? So Y1, if I haven't defined it, so that's the default value for any parameter that hasn't been assigned, just takes on a default of 1. So now if I come down here and I say C equals 80 pi, now it updates, right? So as soon as you change any value of A, B, or C, it updates the value of this expression. Again, so I come over here to negative 5. And then it automatically updates that. So there's no order to lines in GC. Once something is defined in one line, that definition will carry throughout the whole file. Does that make sense? Okay, so there are symbols that are reserved for special use. They're not free parameters the way the capital A, B, and C are free parameters. So here are the symbols reserved for special use. It's lowercase x and y, and that prompts GC to graph. Okay, so lowercase x and y specifically mean graphing. Z also, but Z prompts GC to graph in three-dimensional space. Little t, if you remember from Calc 2, that's the conventional symbol for the parameter and parametric functions. So that also has that meaning. U and V, similarly, if you remember from Calc 3, when we did vector functions of 2 variables, so U and V take on the parameters for multivariable vector functions. Little r is the radius and polar coordinates or spherical coordinates in R3. N, there's something called a built-in slider. We'll do that in a second. So N is a variable where you can manually change its value with a slider. And then E, pi, and I have their conventional mathematical meanings. E to 2.78, and then pi, of course, and then I squared to negative 1. But then all other lowercase and all 26 capital letters are free parameters. Okay, and you can make strings of characters to be a parameter. So we'll see that later. We'll show you that later. Okay, so graphing points and lines. So coming back up here, so I'm going to take C out of here. So to say capital A equals 2 and to say little y equals 2 will be 2 totally different things in GC, right? Capital A equals 2, that assigns the value 2 to the parameter A. But what about y equals 2? What does that do? Right, so little y is telling GC, I want you to graph this for me. I want you to graph all points whose y coordinate is 2. So if you look at your graph, so I got to hit enter. And then the square, if you click on the square, you can choose different colors for the set of points that it's going to plot. So you can choose red. You can also increase the thickness. Sometimes that's helpful. If you've got lots of things going on, it's hard to see. So y equals 2, we'll graph the line y equals 2, all points that have a y value of 2. Plotting points. So plotting the points, to plot a point, you do Control 2. So to plot a point in the plane, you do Control 2. I think we did this last time. And that comes up, and so you get this vertical 2 vector. And so I want to plot the point 1, 1. So you can do 1, and then if you do tab, it'll just highlight the y and hit 1, 1. And so now if I hit graph again, now I have this x'd out, right? So one of the choices in the colors is x means don't show the graph, but save the equation. So now I'm going to do blue. So that just graph the point 1, 1. And then I'm going to do 4, 2. So 4 tab 2. And make that purple. And then 9 grab 3. 9 tab 3. And we'll go back, we'll do black for that one. So the yellow and the green and the light blue, sometimes that's hard to see, especially for like curves and lines and points. It's easier to see when you're doing surfaces and solids. So we kind of tend to stay away from those for like R2 graphs. But hit enter, and so now I've got these points here. So you can zoom in or zoom out down here. Lower left corner has zoom in and zoom out. So the little mountain zooms out. And then the big mountain zooms in. You can also zoom in on just one axis. This is really, really helpful sometimes. We'll see that in a little bit. We'll do something else. But what I want you to do now is I want you to graph a curve that contains those points. So can you graph a curve that contains those points? 1, 1, 4, 2, 9, 3. I want to see on your screen. I want to see a graph that contains those points. Okay, Elizabeth, did you get it? Tell me. Y equals the square root of x. And let's make that blue. Okay, so suppose I just want to show only the part of that from the first point to the last point. So I don't want to see all the points. I only want to see it starting from here and ending here. Did we do this once at the end of class last time? You remember what to do? Anybody remember? How I can show only some of the points. So this is going to show all points for the domain of that. Yeah, do you remember how we do that in GC? So we need a comma. So we're going to do a comma on that line. And you want 1 is less than x is less than 9. And so then that shows just that part of it. Okay, so I'll show you how Zoom is really helpful. Any questions so far? So to graph that set of points that's has that relationship, we're going to use lowercase y and x telling GC to graph, right? Lowercase y and x tell GC to graph. If I did the square root, so capital Y equals the square root of x, capital X, what just happened? So what did that do? What did that line do in GC? Yeah. Right. And so what did it set it to? What value did it set it to? But I didn't. So what did it set it to? I don't have capital X anywhere in this. Yeah, so this is going to take the value of capital X, which is 1, and it's going to take the square root of it, and it's going to assign that to y. So y is like, come on, man, I was already 1. Give me something new, right? So yeah, so capital Y was already 1, and we just assigned 1 to it again. What about now? What if I type capital Y into the next line? What's it going to say? 2, right? It's going to say 2. Now, if I entered a capital X in, that will change Y, right? So if I enter a capital X equals 16, then Y will be 8. So this is, you can see how this could be really powerful, right? Okay, what's next? Oh, so I want to, let's enter in something crazy here. Y equals, say, 50, x to the 5th, minus 87, x to the 4th, plus 101, x cubed. Let's see what that looks like. Nope. Minus 234 x squared. Let's see what that looks like. Trying to get some flippage here. Oh, we do have flippage. Okay, cool. All right, so this is, I've got that black. And so I've got this graph that I can't really make sense of, right? It's just, it's kind of hard to make sense of what's really happening with this graph. So what would help to see kind of a better view of this graph? What would I want to do? So I got some action here along the negative y-axis. I also have what looks like x-intercept here at 1 point something. Oh, maybe over here too. Oh no, this is the side of the screen. So what can I do to make a better view of this? What would I want to do? Zoom in. Someone said zoom in, someone said zoom out. So zooming in. So that's not bad, but I don't get to see that other root to see that. So that's somewhat helpful. But I want to see the whole graph. So what about zooming out? Is that helping? All right, so what do we need to do? Back where we started. Any ideas? I want to get a good view of this graph.
Can you stretch out the x-axis?
Stretch out the x-axis. Yes, I can. So do you mean zoom in or zoom out on the x?
Out.
Zoom in?
Yeah.
Zoom means in. How about
Out,
that?
yes.
Does that help? Kinda.
Kinda.
Still not really seeing all of it, right? So I kind of want to see all this action in the middle of the graph here around the origin. What's that? Oh, okay. So I on a Mac I hit Option, and do you see when you hit Option you get these horizontal bars? See that? So on a PC it's either Control or Shift does that. So when you hit Control or Shift and look at you got to hold it down.
It's a control.
So Control is for the horizontal. So Control gives you ability just to zoom in and out on the x-axis, and Shift is just the y. On a Mac, it's Option and Command. So again, I want to anyone idea what should I do now to see a better view of this?
Zoom out of the graph. of
Zoom
the
out
overall.
normally.
Yes. And then keep
Okay.
zooming to the horizontal axis.
So I think what we want to do is we want to zoom.
Oh, vertically.
Yeah, how would we zoom vertically? So I'm going to reset here, reset the graph. If you go to the graph menu and reset, how do I want to zoom on the y-axis to make this better? Zoom out on the y, right? Zoom out of the y. So that's command on a Mac. I guess that's shift on a. So zoom out would be the small one. Here we go. That's what we want. And then from there, I can zoom in. And now I got a pretty decent view of this. But a terrible view of my square root of x, right? A terrible view of my square root of x graph. Okay, so let's talk more about. Go to the assignments. So first, so just while we're here, you've got the did that. The first critical précis is due Thursday. Does anyone have, while I'm on that, anyone have a question about that's due on Thursday? You're writing like it's longer than a summary or an abstract, but it's shorter than the article. So you're rewriting the article in a condensed form. You want to make sure you hit all the key points that the author is making in the article. But then you're not reflecting, giving opinions, interjecting your own thoughts into it. It's just a rewrite of the article. Then in the discussion questions, that's where you get a chance to reflect and give your own ideas. And you can put that all in one file. Okay, you can put the discussion questions in one file with your critical précis. And that's due Thursday before class. Anybody have a question about that? Okay, and so then I posted a new there's a new module called GC, or a new assignment area called GC assignments. So GC intro part 1 is going to be also due Thursday. Okay, this is also due Thursday. And so we're going to work through pages 1 and 2 here in the next 10 minutes, and then you're going to do pages 3 and 4, but don't do pages 5 and 6. It's actually a 6-page document. Your assignment is to do 3 and 4. Okay? And that's all explained in the post. Okay, so here we go. So here is this first page is an example of this is a formula that calculates your mortgage payment. Okay, based on the rate, the principal, and the number of payments you're going to make. Okay, and so this first page is just saying here's some different scenarios of rate, payment, and number of months, and you're going to use. Can you all see that? You're going to use the just the straight up mathematical formula to crank out values of the payment. So we've already done that with the $50 and the area questions. Okay, so that's that. And then the next page 2 has all the free variables or the special use variables that we talked about. And so on page 2, it's using parameters, right? So we're going to assign R to be this value, P to be this value, N to be this value. So let's just do this quickly. So let's open a new GC file. Got that. Okay. So R equals 0.065, and that's the rate. So you don't want to use lowercase r, because lowercase r is safe for radius in polar and spherical coordinates. Make sure you use uppercase r. And then P is our principal amount of the loan. And then use capital N. Okay, and so then I said you could use strings of letters. We're already using capital P to mean principal, so we don't need also, we can't also have it mean the payment. So to get a string of letters, if you hit backslash, which is the one above return, through backslash, and then you type a string, so capital PMT, and then when you hit backslash again, they go away, and now you just told GC that PMT is a single unit, which is a new parameter. So PMT is capital PMT now, is just, it's a parameter just like capital N or capital P or capital R. And so we want to, and notice, look, it has a value of 1, see? Now, had I not used the backslashes and did PMT, then it's going to interpret that as multiplication. It's going to be P times M times T. But with the backslashes, then it forms it as one parameter, okay? So we want to define, here's our payment formula for the mortgage. It's capital R divided by 12 times P times 1 divided by 1 minus square root 1 plus capital R over 12. And that to the minus M. So now it just, since R, P, and N have these values, it's evaluating this and assigning the resulting value as the payment. And how can we find out what that payment is? What can we do? How do we have GC tell us what the payment is?
Have a new math line.
And what do you want?
PMT.
PMT, right? So you're just going to write, PMT has a value now. So as soon as you enter it in, it's going to tell you. So this is your payment on the loan that has that rate and principal and the number. It's a 30-year loan, right? Number of payments, 360. So you see that if you were doing a table of these, this would be a lot nicer than having the parameters set on separate lines. Would be a lot easier than having to do it on the page one way of changing these numbers and the expression and just doing it, right? So parameters make it really nice because I can go to the next line in the table here, which is for 0.065 interest rate, a 6.5% interest rate, and 50,000 principal, and 480. So all I have to do is change those values, and then the formula updates the payment, and now here's the payment for that set of parameters. Okay, does that make sense? So you're in page 3 and 4 is about doing the same thing again, but then this time using function notation. So let's just get started with that together. So function notation. Does GC recognizes function notation just as it were defined in just the conventional way in mathematics? Okay, so when we do function notation, so we can use our favorite function name f, right? F is the most common function name. These parentheses that we need for function notation, though, if we use Shift 9, what will happen? What does it think that we want? Multiplying, right? It's little f has a value of 1, and it's saying, oh, you're gonna ask me to multiply f times what's in the parentheses. We don't want that. We're trying to define a function. So what you have to do is Control 9 gives you the parentheses for functions. Control 9. Super important. So this particular function is a function of the rate, so capital R, capital P, capital N. So that's a function of 3 variables. And I can just copy and paste. It's the same formula as for payment, but now it's going to assign values to the function f, right? The function f. So I can copy and paste. And so now if I want to know how could I get use my function to get the value of the payment for this scenario, what would I do? So Angel, what will I do if I want to use my function now to get my payment for this scenario of rate, principal, and payments?
You would just type in f of, and you want me to use those values?
Yes, for this one.
You do f of, and then you do 0.0625, comma 500,000, and then comma 480.
Did it give me the same payment as the formula?
Yeah.
So one big theme in this course is going to be functions and function notation. And my goal by the end of this course is that you have your mindset, you have a way of thinking that is in line with functions and function notation. That you come to appreciate that, and it will be a natural thing for you to lean towards, to use. That's my goal. Okay? So both of these, this payment formula and this function definition, both got me the same result. But one just open-ended question here. What advantage is there to one or the other? Is there an advantage to just having a straight-up formula? Or is there an advantage to having a function definition? Okay? So that's a discussion we'll certainly have.